Okay, here we go. Limits, day 3. So what are we going to do? We're looking at piecewise functions algebraically, and they're asking us to find very specific things. So this is getting us ready for our Delta Math homework and our Delta Math test. And so this is what they're asking us to find. So our f of x is right here. This is our piecewise function, and they're asking us to find the limit of this function as x approaches 4 from the left. So let's stop for a second, and let's get a number line here. And let's put a 4 there. So if we're approaching 4 from the left, we're coming this way. So we're looking at what? 3, 2, 1. These are the numbers that we're looking at. And so we have to decide which one of these, this one or this one, is coming from the left. And so this says x is greater than 4, which is this side. And this is x is greater than, x is less than or equal to 4, which is the side that we want, right? So that's the first thing that we want to do is we want to say, okay, which one of these are we going to use, this rule or this rule, right? And so by thinking about the number line, and once again, you don't have to think about the number line. You can do it a little bit differently, but we know, hey, we're actually going to be using, because x is less than or equal to 4, we're going to be using this rule right here, this part of the piecewise function. And so we're going to rewrite this as limit as x approaches 4, approaches 4 from the left of 10 minus x squared. And we know what we can do. We can do direct substitution. There's no issues here. We're going to plug 4 directly in, and we're going to get 10 minus 16, which is negative 6. All right? So the hardest part about these types on Delta Math is deciding which rule to use. Do we use the x minus 1? Do we use the 10 minus x squared? So however you want to do it, number line works. Let's try another one and see what we can do. All right, once again, we've got a piecewise function. It's asking us to find the limit of this function as x approaches negative 3 from the right. And so we can do that number line and can think, okay, from the right means we are coming from this way, right? So all the numbers bigger than 3. So now you see this is what we're looking at. So then this is our rule, or this is our function. This is our part of the piecewise function that we're going to be using. So here we go. We're going to write that. We're looking at the limit as x approaches negative 3. We already know from the right because we picked the one that was right. Why did it do that? I didn't even touch it. All right. So we're going to just do direct substitution. And when we plug in negative 3, don't forget that the whole thing gets squared. So negative 3 squared is 9. 9 minus 6 is 3. And that is our answer. All right. Let's try another one. Here, we're like, oh, this one's different, right? Because this one's asking us to find the limit of the function, of this piecewise function, as x approaches negative 3, period. All right, so when we're looking at negative 3, it's saying approaching from the left, approaching from the right. So we're talking about all of the x's, all right? So we're not just looking at this, we're looking at this, which is crazy. How can we do both at the same time? So basically, we want to remember something we learned that first day, that left-sided limits, if they're the same as the right-sided limit, then we've got a limit altogether. So that's what we want to do with this one. We want to say, okay, let's go ahead, since this is x is greater than, this is my right side limit. So we'll do limit as x approaches negative 3 from the right, and we know we're using this for that. That's 3x plus 7. We can do direct substitution, so we're going to plug in. Did I do a negative 1 there? That should, is that, oh, that's positive. Okay. So we're going to plug negative 3 in, so it's negative 9 plus 7 is negative 2. All right, that's good. Let's go ahead and do the other. Let's do a new color. Let's do turquoise. Let's do the limit of the same piecewise function, but this time coming from the left, which is going to be this. Okay. And let's plug in that negative 3, 7 minus, now negative 3 squared, right, is positive 9. So 7 minus 9 is negative 2. Oh, they're the same. See how this and this are the same? If our left-sided limit, our right-sided limit, and our left-sided limit are the same, then our overall limit is equal to the same thing. It's equal to negative 2. So pretty cool. All right, let's keep going. We're doing good. All right, same thing here. We're asking for the overall limit. So we want to do both sides. We want to take the limit of as x approaches -2. If we use this, we're coming from the right because it's greater than, coming from the right. We're going to use direct substitution. So we plug in -2. What do we get? -6 plus 8 is 2. All right, let's switch colors and let's do the other side. Let's approach this same function, or let's approach -2 from the left. And so from the left, we're going to be using this. And let's see if we plug in. What do we get? -2, that's going to be a -2 times 4, so that's -8, plus 4 is -4. Oh no, they're approaching two different values, and we know that we're going to have a gap there, right? From the left, from the right, we're approaching 2, but from the left, we're approaching -4. We are never going to meet up, so we would say this whole limit right here is equal to a limit that does not exist. So if my left-sided limit or my right-sided limit does not match up with my left-sided limit, the limit does not exist. All right, I think this is where we're going to stop. If you're at home, go ahead and stop and do day 3 mini practice. Ask me questions if you're in class for some reason. Well, if you're in class, I'm teaching it. So, all right, you know what I mean. Let's keep going. All right, so now we've got something new to learn. We've got 2 special trig limits. You didn't think trig, we were done with trig, did you? All right, so do we have to memorize these? We do. We do. So we'll use them enough on Delta Math that I think we'll be fine. So one of the ways that I like to remember them is that, see how this one's equal to 1? Well, sine has a 1 in it. And see how this one's equal to 0 and cosine has a 0 in it? I don't know, you know, those little goofy things, they can help. So let's do this, because at first glance, kind of looks like, oh, we're going to use the one with cosine, right? Well, so what I'm going to do is I'm going to factor out that 6 and see what we have left. So when I'm going to go ahead, I'm going to take out the 6, and I'm going to say, and all of a sudden I'm like, oh, wait a second. I remember my identities, right? 1 minus cosine squared, who is that? That's right, that is sine squared, right? We know that. Hopefully you didn't forget. That was our, well, okay, that wasn't our last unit. Well, depending on what year you're watching this. So if you forgot, hey, that came from cosine squared plus sine squared equals 1. So when I see 1 minus cosine squared, that means that I just took, or someone took the identity and moved it around. So we have sine squared equals 1 minus cosine squared. All right, so here we go. So we're like, wait a minute, now the problem just shifted, didn't it? Let's get back our green. So the problem just shifted. We thought we were going to be using the cosine one, but now we're like, wait a minute, this is going to be 6 times sine squared x over x squared. And then we're looking at this sine squared one, and man, I have so much up here. Let me erase some of it so we can actually see. So we're looking at this sine one, and we're like, well, Miss Overby, it's sine x over x, and we got a 6, we got sine squared over x squared, and you're right. So what we're going to do is we're going to break it down so we can actually use this limit formula. And so we're going to take the 6 out, and that leaves us with what? Sine squared x over x squared. How about, is it okay with you if I rewrite that instead of writing sine squared x over x squared, if I wrote it as sine x over x times sine x over x? Okay, is that okay with you? Because that's the same thing, right? These two are the same value. Now we're allowed to find the limit of things separate. Like I normally wouldn't write it this way, but I want to the first time so that you know I actually can do this, or you can do this too. We can break it down into 3 limit problems, okay? And so if we do this, now once again, you don't really have to write this part. We'll just have that agreement from here on out. But if you write it this way, then we're like, oh, First of all, the limit of 6 as x approaches 0, well, think about it. The function 6, or the 6, is the function y equals 6. So that's the line, 1, 2, 3, 4, 5, 6, right? It's this line. I don't care what x we're approaching, y is always going to be 6. And so that's why whenever we take the limit of a constant, it's just the constant itself. And then we're looking at, wow, right here is our new rule right here, our special trig limits, that the limit of sine x for x as x is approaching 0 is equal to 1. So we've got this part right here is equal to 1, and that part right here is also equal to 1. So what do we have? 6 times 1 times 1, so we have 6. So the answer is 6. All right, let's do another one. Oh, where'd it go? All right, evaluate this. All right, so one thing I should have said that I needed to say, let's go back here, because we jumped right into doing it, right? And darn it, what's the first thing we always need to do when we see a limit problem? The very first thing, direct substitution. So we didn't. So let's come back here and look real quickly. What would happen if we plug 0 in? So we'd get cosine of 0. Y'all remember cosine of 0? 1. So we would have gotten 6 minus 6, which is a 0 on the top, and then 0 squared is 0. So another indeterminate form. We had to do something. You know why I'm saying that? Because look at this. This looks like what a mess. And so let's plug 0 in and see what happens. If I plug 0 in, well, I get a 7. And then I get minus cosine of 0. Cosine of 0 is 1. Oops, we're not multiplying, we're subtracting. Is 1. And right, remember that unit circle, right? Right here, when cosine, when the angle is, I'm sorry, why did I write 0, 1? What a crazy thing I just wrote. That is 1, 0. All right, so when your angle is 0, your cosine is 1. All right, so we've got 7 minus 1 minus 10 times 0, which is 0. And then we have 3 times 0, which is 0, minus 1. Oh, we're going to get an answer just from direct substitution, which I love. 7 minus 1 is 6, and 6 over negative, I'm sorry, yeah, 7 minus 1 is 6. 6 over negative 1 is negative 6. So yay, be on the lookout for those on Delta Math. Because why go through pain and suffering if you don't have to? Direct substitution first. All right, let's see what's next. All right, let's try direct substitution. Darn it. Let's see what's going to happen. If I plug in 0, we're going to have Okay, let's stop for a second and look at the angle 0, right? Which is right here, where our terminal side did not separate from our initial side. And we've got 1, 0. So remember, tan is sine over cosine, right? And so sine in this case is 0, right? So we have 0 over 1. So we know, bummer, we can't do direct substitution because we'd have a 0 here, which would make the whole thing 0, and then a 0 in the denominator. We don't want that. Well, it's an indeterminate form, so we can't really do anything with it. All right, so here we go. Switch up our colors, get back to that avocado green, and let's see what we can do with it. So I'm going to rewrite it real quickly. And I'm going to be thinking, this is looking like I need to apply some of my identities, right? Some of my trig identities. So I look at negative 5, can't do anything with that. And this is another thing I'm going to do, if it's okay with you. I'm going to separate this, because negative 5 is negative 5, then this and this. Ooh, hope you like that. Hope you're okay with that. So I'm going to have negative 5 times cosine x over x times tan x. You know what? You don't have to break it up this way, but my next step, you have to figure out how to make that work. So let's see. My next step is to say, I'm going to change that. Let's rewrite the limit to remind ourselves we're in a limit problem. I'm going to rewrite the negative 5, rewrite that. But I'm going to take that tan and I'm going to write it as sine x over cosine x, right? And when we do that, we're like, oh, that is great. Our cosine x's cancel out, all right? So let's see what happens next. We're going to go ahead and, man, I'm writing so big, aren't I? All right, so now we've got the limit, x approaches 0, of negative 5 times, and I'm going to separate it with a parenthesis, sine x over x. So we're like, we can do this. Now we can break it down into two separate things, right? And I'll do that one last time. But once again, you don't have to once you understand how it works. If we take the limit of a constant, no matter what number we're approaching, the constant is going to be our answer. So we're going to do two of them. We're going to do the limit approaches, the limit of negative 5 as x approaches 0, and the limit of sine x over x as x approaches 0. We already know that this part is 1, right? So negative 5 times 1, bam, negative 5. Do we get to use the cosine one at all? Let's see if we're going to. Maybe this time. Okay. Nope, we're going to do another sine one. So it's interesting that I did, and that's all we're going to do. This is our last one. So that's okay. The cosine one's pretty straightforward when you see it. So you know what? You can ask me in class if that doesn't make sense. But yeah, the cosine's pretty. It's the sine that we do a lot of little extra clever work. So that's why I'm focusing on that. All right, so let's look at this, and I'm going to rewrite it. And I'm also going to say, oh no, right? What is going on here? Let's do turquoise. So what's going on? We know that we're going to use, let's write it, 4x. Okay. We know we need to get it like this, sine x over x. Yet we have sine 6x over 4. So, all right, so we're going to split some things up. See this 9 and the 4? I'm going to separate those. Now, I'm not breaking any algebra rules. I'm allowed to do this. And you tell me if times sine, make that bigger, sine 6x over x. All right, do you agree these two things are the same? I didn't break any rules. All right, now let's talk about this right here. Okay, let's talk about this. This says sine of something over that same something. So I can also understand this, like in this case, yeah, I have sine of 6x. If I had sine of 6x and I had it over 6x, then I actually could still apply the special trig limit because it's still sine of something over that something. Who cares if the something looks a little different? It still works. So we're like, okay then, let's just put a 6 there. So let's come over here and Ms. Overby, let's just put a 6 there. Now, are we allowed to just plop a 6, multiply the denominator by 6? We are not. But if we're, and I'm going to go ahead and rewrite this. Let me undo that little 6 part because this, we'll undo it in little pieces. Okay, let's come back and rewrite so that it makes sense what we're doing. All right, we've got the 9/4. Okay, we're going to keep that separate. We've got the sine 6x over x. Okay. We know we want a 6. We want to multiply that denominator by 6. Okay. And so we're going to go ahead and do that. But to make up for it, we have to multiply the numerator by 6. You know, I'm going to do that just a little bit differently. Watch. I'm going to go ahead and just multiply everything by 6 over 6. Because guess what? I can multiply anything by 1 in disguise, and it doesn't change anything, right? So let's go back to turquoise because I'm going to zoom up here. So now I'm going to rewrite this. I've got the limit, x approaches 0. I've got my 9/4. Now, this 6 down here, I'm going to put that in with the x. It is okay because I'm just multiplying everything. So 4 times 6 times x is the same thing as 4 times 6x. Same thing. This 6 stays. So I'm going to keep this 6 up here, and then I'm going to rewrite it this way. So it's just being clever. It's being super clever, and we're allowed to be clever because we are. We're just clever people. All right, so we already know. Let's extend this page. We already know, and we're not going to break up the limit unless you really, really want me to do it again. We already know that the limit of sine of something over that same something, we know that this limit is 1, right? We also know that the limit of a constant, so a constant are just numbers without any variables in them, is the constant itself. Let's see if we can reduce real quickly. So 2 goes into 6 3 times, 2 goes into 4 2 times, so we're going to have, what, 27 over 2. So 27 over 2 times 1 is 27 over 2. All right. That didn't make sense. Go back and watch. watch me do it again. But for real, ask me questions. If you're at home and learning, when you come into class, ask me questions to whatever didn't make sense in the video. All right, we've got day 3 mini practice, and then we've got our day 3 homework on Delta Math. All right, thanks for joining me. I see you in class.